Hello and welcome to Equity Education, the chemistry version. And today we're going to be doing some more organic, and we're going to be looking at carboxylic acids, their reactions, how we produce them, and some of their derivatives as well. So I'd like you to go ahead and open up your booklet and we will get started. Right, okay, so carboxylic acids and derivatives. So the functional group of a carboxylic acid is COOH, which looks like this. Okay, and when we talk about its derivatives of carboxylic acids, usually what we're talking about is, I'll draw it out so you can see, is that we still have a C double bond O, but we've replaced the OH with something else. We're probably just going to talk about acyl chlorides and maybe a bit about amines and amides, but not that much. Okay, so moving on. So solubility and water. So carboxylic acids are very soluble in water, because they form hydrogen bonds with the water. Okay, so I would like you to have a go at drawing a hydrogen bond connecting with a water molecule and this carboxylic acid molecule, and I will give you a couple of minutes. Okay, and I'm sure you've drawn something like this. So here's my water molecule. Don't forget to put the dipoles on, so delta positive, just like I've done, delta positive and delta negative, your lone pairs. And make sure that your hydrogen bond comes from the lone pair of an oxygen to a hydrogen atom. Okay, so something that looks like this. Okay, moving on. So our general formula. So our general formula for a carboxylic acid is RCOOH, where R is an unknown alkyl chain, so carbon and hydrogen. Moving on, so boiling points. So carboxylic acid, the boiling points are high, and they are solid at room temp. I've left enough space. And this is because they can form dimers in the absence of water. So they form dimers with each other. And I've drawn two carboxylic acids out here. So I've got a molecule of ethanoic acid here, and I've got a molecule of ethanoic acid here. I'd like you to just think about where the dimers might form. Okay, so where the bonding might happen. Okay, and as you've probably guessed, we're going to have some type of bond between our oxygen on this carboxylic acid, C double bond O, and the hydrogen atom on this carboxylic acid. And unsurprisingly, these are hydrogen bonds. Now we know hydrogen bonds are strong intermolecular forces, hence why they have quite high melting points and they're solids at room temperature. Okay, moving on. So examples and naming. So I've drawn some out. I'd like you to have a go at naming. Oh, just before you do that, there's going to be quite a lot of exercises for you to do. If you don't know, maybe do it in pencil, and then you can go over in ink. Okay, right. So have a go at naming these. Okay, I'm sure you've worked out at least at first two anyway. I forgot to mention that it ends in oic. When we're talking about carboxylic acids, ethanoic acid, butanoic acid, propanoic acid. Sure you know that already. So our first one, we have the longest carbon chain is 1, 2, 3, so propanoic acid. Here the longest carbon chain is 1, 2, 3, 4, so butanoic acid. However, I have a methyl group on the second carbon, so 2-methyl butanoic acid. And one you may not have seen before, so a benzene ring with a carboxyl group coming off, and we call this benzoic acid. Okay, so moving on. So forming a carboxylic acid. So I can form them through oxidation, and usually it's oxidation of a primary alcohol. So I oxidize a primary alcohol. Okay, and I can use lots of different reagents to oxidize. However, the most common is acidified potassium dichromate. E.g., for example, so I might have a primary alcohol such as ethanol. Remember, when I'm doing this, I would write it as my oxidizing mixture as an O to form my carboxylic acid, and 2, 4, 4, 5, 6 plus H2O. Let's make sure I balanced it. Go back and balance your oxygen. So 1, 2, 3, 2. Okay, so I've got my primary alcohol, which is ethanol, and I form my carboxylic acid through oxidation. Remember, this is complete oxidation. And I'm not going to go through this anymore because we've had lots of videos based on this. So complete oxidation. Okay, so for this to happen, we need to warm or heat. Let's write heat. And reflux. Okay, so this is one method of forming an carboxylic acid, which I'm sure you've seen before in its oxidation. Okay, next one is the hydrolysis of nitriles. So nitriles. Okay, so nitriles, the general formula of RCN. So they have a CN, and it's usually at the end. And we can have acidic and we can have alkaline hydrolysis. Okay, so my general equation for forming a carboxylic acid from a nitrile in acidic conditions is this. Plus an ammonium ion. Okay, so this is what I would like you to do. I'm going to give you the formula of a nitrile, and I want to see if you can figure out what the rest of the equation is. So I'm going to give you this. This is my nitrile, and I name this as, it's got 2 carbons, so ethane. It's got a CN, so I call it ethane nitrile. Okay, so your turn to see if you can fill out the rest of the reactants and the products. Okay, I'm sure you all managed to do this. So all we're doing is following our steps in the top, but you needed to know that we're going to form ethanoic acid, which isn't very difficult because you've got 2 carbons here. So all we've done is add some oxygen, the C double bond O and OH. What we actually get produced is ammonia, but because it's in acidic conditions, we can add a H plus to the ammonia to produce an ammonium ion. Okay, so moving on, so alkaline hydrolysis. So again, we're going to do something similar to what we've just done. So we're going to write the, general equation. So nitrile plus H2O plus OH minus goes to carboxylate ion plus ammonia. Now I know I'm using a mixture of chemical formulas and words. I'm using the words because I want you to work out what the chemical formulas are. H2O, you know, is water, so you can just write it out. You should know this is hydroxide, and example, this is an acid as well. Okay, so let's give you another one. So let's do it with this nitrile. So I'd like you to have a go at naming this as well. Remember the carboxylate ion. Have a go, see if you can work it out what I mean. Okay, so this was slightly more tricky. So because it's in alkaline conditions, what actually happens is that the carboxylic acid which is created can react with the OH minus, and we get the NH3 produced, so the ammonia. If I was using sodium hydroxide, I would get sodium propanoate produced. However, I'm not showing the I'm not showing the Na here, so sodium hydroxide. I just said it's a source of hydroxide ion. If I had been, we would have the Na plus on the end, and it would be sodium propanoate. Okay, so I've formed my propanoate ion. Yep. Okay, so the next thing I need to do, because this is the formation of carboxylic acids, so this is my step 1. My step 2 is to acidify using H+. So CH3, CH2, COO minus plus H+. And it forms my propanoic acid. Okay, so moving on. So very similar to what we've done. I'm going to get you to have a go at doing these. Maybe do it in pencil, just if you're unsure. So reactions of carboxylic acid. So general acid-base reactions. So you should know the general reactions of an acid. Okay, so acid plus base makes something and water. I've given you a word equation, so ethanoic acid plus something goes to sodium ethanoate plus something else. And then you need to do a chemical reaction, so the chemical formulas of the reagents and the products on the third equation. Okay, have a go. You should be able to work out what the different gaps are from what I've given you. Okay, sure you figured this out. So acid plus base makes a salt plus water. My acid is ethanoic acid. My salt is sodium ethanoate. Remember the definition of a salt is when a H plus of an acid, so it's be my ethanoic acid here, is replaced by a metal ion, so my sodium ion, or an ammonium ion. Yep. So because it's sodium ethanoate, I know that my base must be sodium hydroxide, it probably will be sodium hydroxide. I could have said an alkali here to be a bit more specific. And this is the formula of my salt, so sodium ethanoate. And I've put the minus and the plus on. You don't have to. You can just leave it as COONA. It's up to you. Make sure it's balanced. Okay, so if you've got the idea, I'd like you to have a go at the next one as well. So general equation, and then you should be able to work out the rest. Okay, so this one was slightly more tricky. So acid plus metal makes a salt plus hydrogen. You should know that. My name of my salt is magnesium propanoate. That means my metal must be magnesium. And the propanoate, so the acid must be propanoic acid, obviously hydrogen. You need to know that Mg has a charge of 2+, which means that we're going to need 2 molecules of my propanoic acid, because that only has a 1 negative charge. So my propanoic ion will be in brackets 2 Mg plus H2. Need to balance it up with a 2 moles of propanoic on this propanoic acid on this side. Okay, so a little bit more tricky. Okay, next one. Right, so you've probably got the gist now. Your turn again. Have a go at doing this. Okay, a little bit tricky again. So acid plus metal carbonate makes salt plus carbon dioxide plus water. Didn't really leave enough space there. My word equation, so I had methanoic acid plus sodium carbonate. So I must make sodium methanoate plus carbon dioxide plus water. And students seem to get confused with methanoic acid. So the structure of methanoic acid, it only has 1 carbon in it. Therefore, this must be the carbon. So the only thing we have attached is a hydrogen here. So this is my formula for methanoic acid, which means I'm going to make sodium methanoate and carbon dioxide and water over here. Make sure you balance it, so you need 2 moles of the methanoic acid. Okay, also don't forget sodium carbonate. So carbonate has a charge of 2-, sodium has a charge of +1, so I need 2 sodium ions. Okay, right, so moving on. So again, your turn. We're doing this basically because there's not going to be many questions at the end of this, because I'd like you to have a go at just working out the formulas of different organic compounds. Okay, that's the hardest thing that you'll have to do, is to recognize the organic compounds and get used to remembering the different types of reactions. Okay, right, so over to you. Esterification. So I've given you the general formula. An alcohol plus carboxylic acid makes an ester plus water. So this is an esterification reaction involving a carboxylic acid. Okay, think you know what you're doing, so have a go, maybe in pencil. Okay, so have you remembered how to name our esters? So alcohol plus carboxylic acid makes an ester plus water. The ester I've made is methyl ethanoate, and that means that the ethanoate comes from my acid, so the ethanoic acid, so the methyl must be from my alcohol, so it must be methanol, and my formula down here is CH3OH, which is methanol, CH3 C double bond OH, and here is my ester bond, C double bond O, O in the middle of 2 carbon chains. So just in case you've forgotten, so my methanol is the first part of the name, so methyl, and the second part of the name is my carboxylic acid, ethanoate. However, when we draw them, usually we draw the carboxylic acid bit first and the alcohol at the end. You can draw it the other way around, but this is the usual notation. Okay, so conditions. So for this to happen, we need to have concentrated H2SO4, and we need to warm and reflux. So the concentrated H2SO4 is to act as a catalyst to push this to this side, and I've just noticed, technically, let's be correct about this, this is a reversible reaction. That's why we use concentrated H2SO4. I won't go into too much detail about that because there's a separate video on esters. Okay, so forming an acyl chloride. Right, so again, I'll let you have a read through, see if you can figure it out. Do I need to give you any tips? Yes, I probably do. So an acyl chloride looks like this. So the general formula of an acyl chloride is this. So instead of the OH, we have a Cl and then an R chain on the carbon chain at the end. What have I used? So I've produced propanoyl chloride. I reckon you probably can work out what the structure of propanoyl chloride will be. Now I've given you the general formula. Okay, have a go, maybe in pencil again. Okay, right, so I forgot it was nice, so I gave you the structure of propanoyl chloride down here. So if I've got propanoyl chloride, it must mean that I'm using propanoic acid. We react it with sulfur dichloride oxide, which I've given you down here as well, and we produce our propanoyl chloride, sulfur dioxide, and HCl gas. This is something you just gotta remember, okay? So practiced it. So carboxylic acid plus sulfur dichloride oxide will produce an acyl chloride plus sulfur dioxide plus hydrogen chloride gas. Really should have written that out, but I ran out of space. Okay, conditions. So the conditions are important. So we need to make sure that we have anhydrous conditions, and it happens at room temperature, and the reason being is because we produce this hydrogen chloride gas. So if we produce this hydrogen chloride gas, HCl gas will fume in moist air. And we don't really want lots of HCl gas knocking around because it's not very nice. Okay, so moving on. Oh, sorry, and I just put the state symbols in here because these are important. So liquid, liquid, liquid. Let's make that a bit clearer. Liquid, liquid, gas, and gas. So the important bit is the gas here. We also produce sulfur dioxide, which isn't a particularly nice gas either. Okay, so moving on. Right, so we form these acyl chlorides. So these are derivative of carboxylic acids. As we said, if we go all the way to the top. So the C double bond OX. So we've replaced the OH with a Cl. Okay. So reactions of acyl chlorides. So what are they? So acyl chlorides are liquids with a pungent odor that fume in moist air. So they can fume in moist air just like our HCl gas can as well. And our general formula, as we said at the top of the page, is RC double bond OCl, and our names, that ends in oil, as you've probably worked out from our last example using this. So propanoyl chloride. Okay, so acyl chlorides are very reactive, and reactions are difficult and dangerous to control. The reactions are generally very exothermic and produce HCl gas as a byproduct. And as we said, we don't really want to make that many HCl gas, especially not in moist air. Okay, so our general formula for their reactions are acyl chloride plus HX will form X plus HCl. So I can replace my Cl with X, whatever my X is, and I form this HCl gas at the end. Right, so another one for you. So hydrolysis. So I can hydrolyze acyl chloride. The general formula is an acyl chloride plus water forms carboxylic acid plus hydrogen chloride gas. Okay, and you can just can you name the acyl chloride and the carboxylic acid just below it as well? Okay, have a go at this. Okay, I'm sure you've worked this out. So my acyl chloride is ethanoyl chloride. We said we produce a carboxylic acid and HCl gas, so this is what we're going to produce. So this is another way to form carboxylic acids as well. So we produce our ethanoic acid. Okay, our conditions, because it's very exothermic, obviously it will happen at RTP, room temperature and pressure. Okay, so next one. What are we doing now? So we're doing esterification. So acyl chlorides can also produce esters. So instead of using a carboxylic acid, I can use an acyl chloride instead. So acyl chloride plus alcohol forms ester plus hydrogen chloride gas. Okay, back to you filling it out. Okay, have a go. Okay, I'm sure you managed to fill this out. So again, it's a bit of practice on naming esters. So my ester was propyl ethanoate. We know that the propyl bit is from my alcohol, so it must be propanol, and I've given you the formula down here. So my, oh dear, what have I done? I've done ethanoic acid. So this isn't right, is it? So this should be ethanoyl chloride. Let's try again. So we're not doing acids, that's the whole point of this. So acyl chloride is ethanyl chloride, which means that I will be using this, so that's my ethanol chloride, plus the propanol to form my ester. So propyl, remember this is the alcohol bit, and this is from my acyl chloride, not from my acid. So the ethanoyl chloride. Okay, conditions. Unsurprisingly, because acyl chlorides are very reactive, happens at room temperature and pressure. Okay, next one. So another type of esterification. So we're using an acyl chloride again, but we can react it to form an aromatic ester. So I'm going to use my phenol, and I'm going to produce ester plus. We're definitely not going to produce water. Let's just change that. I'll be back in a sec. Okay, I've corrected. So let's try again. So an acyl chloride plus phenol makes an aromatic ester plus hydrogen chloride gas. So I've given you your acyl chloride, I've given you your phenol. See if you can work out what that is. Okay, slightly technical hitch there. So I assumed you worked out that you had to work this out yourself. So here we go. So this is what we have. So we formed our aromatic ester, so our phenol has replaced our alcohol, therefore it's going to be the first part of the name, so phenyl, and my acyl chloride replaced my carboxylic acid, so that will be the last part of the name, so ethanoate. Can make it a bit clearer, so here's my phenyl, and here's my ethanoate. Okay, and it needs to happen at room temperature and pressure. Okay, so forming a primary amide, so acyl chloride. Now, forming primary amides and secondary amides, or forming amides. So all I want you to do is just remember these. There's another video on amines. Okay, so if you want more details, then go to your amines videos. So I've already written this out for you. So acyl chloride plus ammonia forms a primary amide plus HCl. So this is my acyl chloride, ethanoyl chloride plus ammonia forms my primary amide. This is my formula for primary amide. My reagent to form this primary amide, I need to use ammonia. And to form a secondary amide, I would use an amine. This is my formula of an amine, and this is my formula of a secondary amide. Okay, so you may need to copy that down. I've gone through that quite quick, but as I say, there's another video on it, so I would watch that one. Right, so no questions at the end of this because you've been working pretty hard throughout this video. So hopefully it was useful, and I will see you next time. Okay, bye bye.